Hello students, we are going to study chemistry chapter classification of elements. In this video we are going to study modern periodic table. In the previous videos we have studied Mendeleev's periodic table. So in later years, after Mendeleev made classification on the basis of atomic weight of the elements, scientists started to understand that atomic number was more fundamental property than atomic weight. So it was true because chemical properties of the elements are due to their atomic number. Based on this change concept, Henery Moseley in 1913 stated modern periodic law. Okay, actually he revised the periodic law given by Mendeleev. Okay, and it is stated it can be stated in this way: physical and chemical properties of the elements are periodic function of their atomic number. Okay, so Henery Moseley replaced atomic weight by atomic number. So on the basis of this modern periodic law, on the basis of this statement given by Henery Moseley, Bohr, another scientist, made the modern periodic table or long form of periodic table. And this modern periodic table is considered as the most appropriate classification of elements so far, and there are in total 118 elements in it now. So characteristics of modern periodic table. Before we get into deeper study of modern periodic table, we need to understand characteristics or the main points in the modern periodic table. Okay, so this is modern periodic table. This table is made on the basis of increasing order of atomic numbers of the elements. Atomic numbers are given here, upper left corner. Okay, upper left corner are atomic numbers of the elements: 1, 2, 3, 4, 5, and so on. Okay, these are kept serially. So while doing this, there form 7 horizontal lines: 1, 2, 3, 4, 5, 6, 7, which are periods. Horizontal lines are called periods, whereas there are 18 vertical columns. You can see vertical columns 1, 2, 3, 4, 5, 6, up to 18 in this corner. No, so these are all groups. Actually there are 9 groups, and 9 groups are divided into subgroup A and B. That is why there are 18 columns in this table. Now if you look at the table carefully, there are particular positions for metals, non-metals, and metalloids. Okay, metals, non-metals, and metalloids have their own positions in this table. So this is an amazing finding. While elements were kept in increasing order of their atomic number, okay, they formed a pattern. Okay, amazing finding. They formed a pattern by itself, and in this pattern we can see all metals are in left side of the table, non-metals are in the right side of the table, metalloids are in the middle of metal and non-metal, and inert gases are at the extreme right of the table, right? So this way there are positions for metal, non-metals, and the metalloid. So here in this way you see number 1, vertical column number 1 to 12. 1 to 12, these are all metals. These are all metals. Okay, number 13, 14, 15, 16, 17, 18, these are all non-metals. Okay, number 1 to 12 are metals. Number 1 to 12 are metals. Okay, these are all metals. Right, and 13, 14, 15, 16, 17, 18 are non-metals. Non-metals, and metalloids are in the middle of metal and non-metal. Okay, metalloids are boron, silicon, germanium, arsenic, antimony, tellurium. These are metalloids. These are metalloids. Okay, so metalloids are the elements which have a few properties similar to metals and few properties similar to non-metal. They come in between metal and non-metal. Okay, so these metalloids occupy somewhat diagonal position in the periodic table in between metal and non-metal, right? So and inert gases, zero group elements are at the extreme right position of the table here. Okay, zero group, these are zero group elements. So you see these groups, actually there are 9 groups in the table. 9 groups are divided into subgroup A and B. Okay, except group 8 and group 0. 8, 9, 10 columns over here. 8, 9, 10 column are group 8 elements. Okay, this group 8 element, group 8 does not have subgroup A and B. And similarly, zero group at the extreme right, zero group elements, these also do not have subgroup A and B. Okay, so two groups, group 8 and group 0, these do not have subgroup A and B, whereas other groups have subgroup A and B. For example, group 1, now see number 1 over here, vertical column, this is 1A. Okay, and number 2, this is 2A. Okay, number 13, this is 3A, and so on. Okay, and you see 1B. 1B is number 11. 1B is number 11, and 2B is number 12. 3B is number 3. So this way, subgroup A and B elements. Now you see group 1A and 2A, these are group A elements, group A. Okay, these are also all group A. These are also all group A. Okay, and these middle part are group B elements. Middle part are group B elements. Okay, so group A elements are also called representative elements. Representative elements, right? And group B elements are called transition elements. Transition elements. Okay, now zero group elements are at the right side of the table. Okay, so representative elements, these group A elements are all representative elements. These follow normal rules and regulations of periodic table, whereas transition elements have special properties in them. You will study about them later. Okay, now this table has separate positions for metals, non-metals, metalloids, and inert gases, or the zero group elements. You understood? Now you see the small part of periodic table is kept below, just below the main table. You can see in here. Now this is the small part of group 3B elements. Okay, you see number, atomic number 57 here. After 57 there is no 58 in the table, but 58 is over here, down here. Okay, so atomic number 58 to 71, these are called lanthanides. Okay, lanthanide series, lanthanide elements, and these elements have similar properties. All the elements have similar properties. And again you see 89 atomic number. After 89 there is no 90 atomic number. 90 atomic number is in this small part below the main table. From atomic number 90 to 103, these are called actinides. Okay, actinoid series, actinides in period 7. So all these elements have similar properties in them. Okay, so this small part of the periodic table has been taken out from the main table in order to avoid unnecessary expansion of the main periodic table. Okay, in order to avoid unnecessary expansion, this periodic table would have been unnecessarily long if this small piece was there inside the main table. Okay, so this way the small part of periodic table has been kept just below the main table, and these are lanthanides and actinides. Upper rows are lanthanides and lower rows are actinides, right? So these are the main points of the periodic table. The first one is elements are kept in increasing order of their atomic number. There are 7 periods and 18 columns in 9 groups. Okay, there are separate positions for metals, non-metals, metalloids, and the inert gases, right? And each group is divided into subgroup A and B, except group 8 and group 0, and lanthanides and actinides are kept below the main table separately to avoid unnecessary expansion of the table. So with this we finish important points, characteristics of modern periodic table. In the next part we are going to study advantages of modern periodic table.